I'm going to do one example in the foldable today, but I just kind of want to talk about it for just a moment. Everybody have it? Your foldable got crushed?
Just one side.
That kind of looks bad. Okay, the main thing I wanted to talk about was the prism. This doesn't have to just be a rectangular prism, so I'm just going to hold them up. Of course, there's more prisms than just these, but the prism formulas work for all three of these because they are all prisms. So I just wanted to explain something to you for just a second. So this is our formula right here for total surface area of a prism, but it depends on what the prism is as to how you do it. So if I'm looking at a rectangular prism and I wanted to know the perimeter of the base, let me call this the base. If I wanted to know the perimeter of the base, I just add all the sides, right? Okay, if I wanted to know the perimeter of this base, I'd add the sides, right? But there's only 3 this time. And if I wanted to know the perimeter of this base, I'd have to add all the sides. The height, that's the same pretty much in all of those. But capital B, what does capital B stand for again? Area of the base. Well, if I wanted to find the area of the base for this shape, I would take what times what? Length times width. That's all I'd have to do if I wanted to find the area of the base for the rectangular prism, is I would take my length times my width. But if I wanted to find the area of the base for my triangular prism, how would I find the area of the base for my triangular prism? What's a divided by 2? Because the formula for area of a triangle is base times height divided by 2. So capital B is found differently for the rectangular prism versus the triangular prism. So if it's a rectangular prism, capital B, we just take length times width, because that's how you find area of a rectangle. If it's a triangular prism, capital B, you want to find the area of the base, and the base is a triangle, you have to do base times height divided by 2. Do you know how I'd find the area of this base? Yeah, I'd have to do 1/2 AP. If I wanted to find the area of this base, this is a regular hexagon, so I would have to take 1/2 times the apothem times the perimeter of it. So it depends on what the prism is as to how you find the capital B. Can everybody hear me? Yes? Okay. So same thing with this volume formula, and we're not doing volume today, but capital B, that's the area of the base. It depends on what the shape of the base is. So if the base is a rectangle, capital B, length times width. If the base of the shape is a triangle, capital B, base times height divided by 2. If it's a regular hexagon or a regular pentagon or a regular octagon, you can find the area of the base by taking 1/2 AP. So it totally depends on what the shape of the base is. Okay? All right, I do want to do one cylinder problem before we get into it. So let's just make something up. What do you want the radius to be? 7. Okay. What do you want its height to be? 12. All right, let's just run with those numbers. I'm just going to do surface area. That's all we're looking at today. And let's just go ahead and find the total surface area. Now, as far as which of these formulas you want to use, it doesn't matter which one you use. Do you guys have a preference as to which one you'd like to use? Would you like to use this one, or would you like to use this, the bottom? You like the bottom one? Okay, so I'm going to recopy the bottom. But if you want to find the total surface area, you are welcome to use this formula or this one. It doesn't matter. Okay, I'm going to leave it in terms of pi. So I'm going to leave the 2 the pi. Now I need to know the radius. And what did we say the radius was? 7. And then h plus r. H is the height. And what's the height? 12. Plus the radius, we said again, was 7. Okay, let's go ahead and work out the 12 plus 7. How much is 12 plus 7? 19. Okay, so now multiply your 2, your 7, and your 19. Don't do the pi. Just the 2, the 7, and the 19. And what do you get if you multiply the 2? 266, and then I'll attach the pi back behind it. And of course, if I wanted to know, what that was as a decimal, I could put 266 pi in my calculator. So that's total surface area of this cylinder that we made up over here. And I'll just go ahead and say meters squared. Surface area and just regular area, those are always square units. Okay, so that's what we're doing today. We're going to find surface area of prisms, not just rectangular prisms, but all kinds of prisms, and then surface area of a cylinder. Okay, a lot of this I don't think I need to go through because we talked about it when we were doing the stuff in the last couple units. When you have a prism, you have two bases. The other sides are your lateral faces. A cylinder, we've seen its net a few times now. It's made up of a rectangle and two circles. So let's just go straight to some problems. And I'm going to use my foldable for my formulas. Okay, for a couple of these, I'm going to do the lateral surface area as well as the total. And then some of them I'm just going to do the total and that's it. So let's go ahead and do lateral area. So what shape are we looking at here? A rectangular prism. The fact that it's a prism, I'm going to look in the prism category, and I'm going to look for my formula for LA, lateral area. And this is what you see in your foldable, capital P times H. So that's what I want for my lateral area. And what does capital P stand for again? The perimeter of the base. And it doesn't say which one's the base. Let's just call this guy down here the base. It doesn't have to be the base, though. This over here could have been the base. It really doesn't matter. If I call this one the base, what would the perimeter of it be? 24. And then what's the height of the shape? 4. And what do you get if you multiply 24 times 4? 96. And how would I label it? 96 inches squared. So that's the lateral area. That's the area of all of your sides. Okay, now let's do total area. So if I go and look at my foldable, I want to look for the total area formula, and this is the one I want for my prisms. So it's the lateral area plus, how many bases does a rectangular prism have? It has 2 bases, so that's why you see 2 times capital B. So let's write that formula down. And I already know capital P times H. What was capital P times H? 96. And then I need to take plus 2 times the area of the base. So if this is my base, what's the area of it?
24 would be 48.
No, the area of this base would be 36. Length times width, 6 times 6, so 36. Okay, take a second and just give me a total answer there.
Yeah. 168 inches cubed.
Inches cubed or inches squared?
Squared.
Still squared. We're still just doing surface area. Today's lesson has nothing to do with volume. Today's lesson has to do with area. This is just the lateral area, and this is the total area. So the difference between the two is if these guys right here are my bases, first I found the lateral area, which is all the sides, and then I attached the 2 bases to it. Okay, this next guy, what shape is it? A triangular prism. So let's just talk about it for a second. How many bases does it have? It has 2. So first I'm going to find the lateral area, which will be the rectangles, and then I'll find the total, which will attach the 2 bases to it. Okay, because it is a prism, so this is, I'm going to write on here, all prisms. We're going to use the formulas that we see in here for the right prism for all prisms. So first I want lateral. And the lateral is the same as the last one, capital P times H. So lateral area is capital P times H. It's just my base is different this time. This time my base is a triangle. How can I find the perimeter of that triangle? The perimeter of the triangle. I will have to use Pythagorean theorem because I know this side is 6, I know this side is 7, but do we know what that side is?
8.
No.
9.
No. Well, we need to do Pythagorean theorem to figure it out. I'm just going to call it x for right now. What would Pythagorean theorem look like?
6 squared plus 7 squared equals
Good. 6 squared plus 7 squared equals x squared. Work that out. Tell me what x is to the nearest tenth.
9.2.
Ooh, guys are fast. Okay, so x is approximately 9.2. And so if I want to find the perimeter of my base, I would take 6 plus 7 plus 9.2. So 6 plus 7 plus 9.2. And what is that? 22.2, is that what you said? Okay, so that's the perimeter of my base. So I'm going to put that up here in the capital P. And then do we know the height of the triangular prism? 16. The height is 16. Like if you think about sitting this triangular prism up on its base's bottom, I know that just sounds wrong, but that's how tall it would stand, is the 16. And what do you get if you multiply? 355.2. And that would be meters squared. Okay, so that's the lateral area. So same formula as the rectangular prism. It's just my base was a different shape, so I had to do it a little bit differently. Okay, the total area. Once again, I'm going to look at the prism formula for total, and it's capital P times H plus 2 capital B. And I do want to see your formulas. So the way I'm working this out, this is kind of what I want you guys to do also. I don't want you to just plug in your numbers in and tell me that you used your calculator. I want to see what formula you're using, and I want to see you plug your numbers into the formula. That's kind of what that activity was about, was trying to get you to figure out what formula you were using and then plugging the numbers into the formula. So do we already know capital P times H? What is that? 355.2. And then plus 2 times capital B. And capital B stands for the area of the base. So let's come over here and talk about how I find capital B. How do I find the area of this base? Yeah, I take base times height divided by 2 because it's a triangle. So what would base times height divided by 2 look like? But like the numbers.
7 times 6 divided by 2.
7 times 6 divided by 2, which makes, what'd you say? 21. So that's my capital B. So that's what's going to go over here. Okay, now you can plug it in your calculator. Uh-huh. What'd you say? Say it again.
397.2.
That's it. 397.2. That's the total area. And once again, it would be meters squared. Okay, so when you guys are doing, and you do have an assignment tonight, when you're doing your assignment for me tonight, I want to see the formula you're using. I want to see you plug in what capital P is. I want to see you plug in what H is. I want to see you plug in what capital B is. And capital B, area of the base, it totally depends on what the shape of the base is. Okay, for the rest of them, just to save some time, let's just do total surface area. So what shape is this guy? A cylinder. So I'm going to look at my foldable for the cylinder, and I want the total surface area. And do you still want to use this bottom one? You like that one the best? Okay. So 2 pi r, and then h plus r. So first thing, like I said, I want to see is your formula. Next thing is you plugging in the numbers into the formula. So I'm going to recopy the 2. I'm going to recopy the pi. What's the radius? 5. And then h plus r. What's the h? 10. And then what's the r again? 5. Okay, you can go ahead and work it out from there. Leave your answer in terms of pi, though.
Is this 60? What about the times by 2?
Yeah, you'll times by 2.
150 pi.
I'm just seeing the
It is. It's 150 pi. Is everybody able to get that, or do I need to explain?
Nope.
You're good? Okay, and that would be feet squared. Okay, let's look at some more prisms. The prisms are the hard ones. Flip. Okay, all I want to do is total surface area, just to save some time. But this is a prism. Do you know what prism this is?
Hexagonal. Trapezoidal.
It's a trapezoidal prism. These are my bases right here, which are trapezoids. So that guy right there is the base, and the guy in the very back there is a base, and the base are trapezoids. So this is a trapezoidal prism. And it's a prism because all the sides are rectangles, and it's a trapezoidal prism because the bases are trapezoids. Okay, but the fact that it's a prism will lead me to my prism part on my foldable, and I want to use the total formula, so capital PH plus 2 capital B. So capital PH plus 2 capital B. Okay, first thing I want to find is capital P. What does capital P stand for again? Perimeter of what? Perimeter of the base. And the base is this trapezoid here. Do we know enough information to figure out the perimeter of this? How long is this? That's 10. How long is this one? That one's 14. Do you know what these are? We don't know. That 8 is this guy right here, but it's not those. So let me talk for a second. I'm going to get out a color marker. If I drew this segment up here, and I drew that same segment up here, how far is it just from here to here? 10. How far is it all the way across it? 14. So do you know what just this little piece right here would be?
2.
That would be a 2. And what's this little piece right here? 2. Is everybody okay with that? If the whole thing all the way across is 14, and I know it's 10 from here to here, that's a 2 and that's a 2? We okay with that? Okay, so if I wanted to know this guy's length right here, do I have enough information that I could figure it out? Okay, so I'm going to do Pythagorean theorem. This is the guy I'm looking for, so I'm going to call him X. What would Pythagorean theorem look like right here? 2 squared plus 8 squared equals x squared. Okay, take a second and tell me what x is to the nearest tenth. 8.2. Okay, so x is approximately 8.2, so that's an 8.2. Do you know what this one over here would be?
8.2.
That one right there would be 8.2 as well. Okay, so now I can find capital P. Capital P stands for perimeter of the base. So what numbers would I add together to figure out the perimeter of this base?
10, 14, 8.2.
Yep, the 10, the 14, the 8.2, and the 8.2. So 10 plus 14 plus 8.2 and another 8.2. Everybody okay with that? What do you get?
40.4.
Okay, so 40.4. So I'm going to go ahead and I'm going to put that into my capital P, 40.4. Okay, if you were to set this up on its base's bottom, how tall would he stand? 14. Good. And then capital B stands for the area of the base. And what shape is my base again? The shape of my base is a trapezoid. So do you remember how you find area of a trapezoid?
Height 1 plus height 2 divided by 2.
What'd you say?
Is it base 1 plus base 2 times height divided by 2?
Yep, that's it. It's your height times base 1 plus base 2 divided by 2. That's your formula for finding area of a trapezoid, and that's how I have to find capital B this time because my base is a trapezoid. Okay, so do we know how tall the trapezoid is?
Yes.
How tall is the trapezoid?
8.
The trapezoid is 8 tall. What are the bases of the trapezoid? 10 and 14, right? 10 and 14. And then I'll go ahead and divide that by 2. And what is that part just right there? $96. And that's my capital B, so I'm going to put it up here where my capital B is. And now I just want to work all that out. Uh-huh. 757.6, and that would be inches squared, and that's my total surface area. So this one was a little more challenging. We had to do Pythagorean theorem to figure out what those lengths were right there because I needed that for the perimeter of the base. And then because the base was a trapezoid, we had to go a little bit fancier for capital B. Okay, this next one, a little bit of a pain. Do you know what this is? Yes, it's a hexagonal prism or a hexagonal prism. But because it's a prism, it's going to be the same formula as all the other prisms. And I'm just going to have you find the total. I'm not going to have you mess with just the lateral. Okay, so capital P stands for perimeter of the base. Do you guys agree that this guy right here is a base? Okay, that's a base, and it's down here too, if you needed me to draw that in. What do you think you know about all these sides? They're all congruent. This is this guy right here. All these sides in this hexagonal prism are the same. So if this is 10, what's the perimeter? 60. Because it would be 10, 10, 10, 10, 10, and 10. So your perimeter would be 10 times 6, which is 60. Everybody okay with just that part? So I'm going to put 60 into capital P. And then how tall does this prism stand? It stands 4. I know it doesn't seem to make sense, sorry. And then capital B stands for the area of the base. What shape is that base? It's a hexagon. What'd you tell me, Autumn, we were going to have to do earlier with this? Yes, if I want to find capital B, I'm going to have to do 1/2 the apothem times the perimeter. We already know the perimeter, we just don't know the apothem. So I'm going to come up here and I'm going to draw in a triangle. So I know this is a pain. Do you remember how I figure out what this angle is right here?
360 divided by 6.
Okay, I take 360 and I divide by 6, which is how much? 60. And the reason I divide by 6 is because there's 6 sides. Autumn, Gavin, come on. If I get that every central angle is 60, what's this one right here?
60.
30. Remember, it's always half. The central angle, this is the central angle right here. This guy that I'm not drawing, this is a central angle. And so this is half of that, so this is 30. I'm going to draw this triangle off to the side here just so it's a little bit bigger. So I know that's a 30. This one's a 90, so this one's 60. Okay, do you know what it is from here to here?
5.
It's 5 because I know that this whole thing is 10. So if this whole thing is 10, that I know that little piece is a 5. So that's a 5. Okay, now let's start our labels. What do you label across from the 30?
X.
X. What do you label across from the 60?
X squared root of 3.
X square root of 3. And across from the 90?
2x.
2x. Did you ever think that you would know those by heart?
Yeah.
Oh, okay. So, since I know what x is, what's this guy?
10. 5 square root.
5 square root of 3. And what's this one over here?
10.
10. Okay, which one's the apothem?
5 square root of 3.
The 5 square root of 3. The apothem goes from the center of the shape to the middle of the side. So this guy right here is the apothem, which is the 5 square root of 3. So I'm going to take 1/2 times the apothem, 5 square root of 3. And we already calculated the perimeter. What did we say that was? 60. Okay. Let's just leave this in radical form. So take your 60 times your 5 and divide by 2. What's that? 150 square root of 3. And so that is capital B, so that's going to come right up here. 150 square root of 3. Okay, see if you can work that whole thing out. And go ahead and give me a decimal. So you may have to be careful on how you plug it in. So take a moment, plug all that in, and give me a decimal to the nearest 10.
Yeah. 759.6.
Good. 759.6. And then that would be inches squared. How did you feel about that problem?
It was easy.
You think it's easy?
Yeah.
So the 1/2 AP, it doesn't bother you anymore?
No, it's just a lot of work.
It is a lot of work, I agree. So just make sure that you remember when you take 360 and divide by how many sides the shape has, that whatever you get there, that angle is always half that amount. And I just blew it up so you could see it a little bit better. Okay, I'm not going to do that last one there because I want you to have a chance to get started. this right here is your assignment, but I'm going to have you do a couple of things. First of all, cross off number 7. Okay, number 1, I just want you to find the lateral area. So number 1, I'm just going to have you find the lateral area. Number 2, I'm going to have you find the total surface area. Number 3, I'm going to have you find just the lateral area. But the rest I want you to do the total on. So find the total area for 4, 5, 6, 8, and 9. But 1 and 3, those are just lateral areas. But 2, 4, 5, 6, 8, and 9, do find the total surface area for all of those. So I'm looking for your formula. I'm looking for the plugging in of numbers. And then I'm looking for the answer. And this does say to show your work on notebook paper, because you'll notice that there is not much space on here to show your work. Oh, there's space? What, for somebody who won't do his assignment anyway? You're probably right.
I can do it. I can do it on the paper. That's $700.
But you've got all your formulas that you need right here in this foldable. Plus they're on this paper so that we did today also. So formulas, plugging in of numbers, as well as answers.
Second chance.
$780 for all my stuff.
Dang it.
What's wrong,